day 727 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3742, maximum path score in a grid. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n grid where each cell contains one of the values 0, 1, or 2. You are also given an integer k. You start from the top left corner 0, 0 and want to reach the bottom right corner n-1, n-1 by moving only right or down. Each cell, each cell contributes a specific score and incurs an associated cost according to their cell values. 0 adds 0 to your score and costs 0. 1 adds 1 to your score and costs 1. 2 adds 2 to your score and costs 1. Return the maximum score achievable without exceeding a total cost of k or -1 if no valid path exists. Note, if you reach the last cell but the total cost exceeds k, the path is invalid. All right, y'all, so that sounds simple enough. But let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input grid equals a 2D array of integers, first array being 0, 1, second array being 2, 0, or it's also an n by n grid, k equals 1. So that means we only have $1 to get from here to here. So let me show you what I mean by that, right? Boom. We copy and paste this over here. So this right here is our grid, and we want to get from here to here while following these rules right here, right? So the best way to reach the maximum, to reach the maximum score, we're going to come from here to here, right? That costs $1, but we have $1, and we get a score of 2 right here. It says, once we come here, come to 2, score 2, total score 2, cost $1, total cost. Boom. So we come right here because remember right here it says it adds 2 to the score, but it only costs 1, and we have 1 to give. So we come right here, we get 2 to the score. Boom. Let's see, score equals 2. Once we come right here, the score is 2. Then we come over here. Boom. Add 0 to the score, add 0 to the cost, so our final score is 2, and that is how we got our output as of 2 when we just went from here to here to here. If we would have went here, 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 then we only would have had a score of 1, right? We want the maximum score, so that's why we took this path like this, and that's this right here, 0, 0, top left, 1, 0, 1, 1, boom, just like that, boom. Now, just in case that didn't make sense, let's go ahead and take a look at example 2. In example 2, our input grid equals a 2D array of integers 0, 1, 1, 2, k equals 1. The output is -1. Explanation says there is no path that reaches cell 1, 1 without exceeding cost, thus the answer is 1. So, let's do this again. Bring this over here. Boom, boom. So in this case, we only have $1 to spend, and there's no way we could get all the way here with $1 because we're going to spend that dollar when we come here or here. So we wouldn't even be able to make it past these two ones, let alone make it to this 2, which we would need another dollar for. So since it's impossible to get there, we return -1, and that's how our output is -1, y'all. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's go ahead and take a look at the fun part, the actual solution. Solution is not that difficult at all. First thing we're going to do is we're going to say let m equal grid.count. Boom. Then we're going to say comma n equals grid square bracket 0. Come outside of that dot count. Boom. Now we're going to create a 3D array. So we're going to come down here, open up, we're going to declare a variable called dp, set that equal to an array, open up the parentheses, we're going to say repeating, sorry y'all, repeating colon, it's going to be another array, open up some more parentheses, and that is going to be a repeating colon another array. Boom, and then this array is going to be repeating colon -1 comma count colon k plus 1. Then we come outside of that, we're going to say comma count colon n, come outside of that, comma count colon m. Boom. Now our starting point is going to be 0, 0 with the cost of 0 and have a score of 0. So we're going to come underneath this and we're going to say dp square bracket 0, square bracket 0, square bracket 0 equals 0. Boom. And now we're going to iterate through every cell in the grid. So for I in 0 dot dot less than m, open up the brackets. Then we're going to say for j in 0 dot dot less than n. Then we're going to open up the brackets. And we're going to get the value at the current cell by saying let val equal grid square bracket I square bracket j. Boom. Then if the cost is 1, if the value does not equal 0, so we're going to say let cost equal val equal 0 question mark 0 colon 1. Boom. Then we're going to come underneath this. We're going to say let score equal val, and this, which will be the score gained from this current cell. Boom. Now we're going to try all possible previous costs used so far. So we're going to say for C in 0 dot 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 K. We're going to open up the brackets, and the best score from the previous cell we're going to declare. We'll set that default value to -1, but we're going to declare a variable called var prev equals -1. Boom. Then we're going to say if I equal 0 and two and signs j equals 0, we're going to open up the brackets, and it's only valid if cost used so far is 0. So we're going to say prev equals c equals 0. Then we're going to say question mark 0 colon -1. Boom. Then we're going to come right here. We're going to say else. We're going to open up the brackets, and we're going to transition from the top cell. So we're going to say if I is greater than 0, we're going to open up the brackets, and we are going to say prev equals max, open up the parentheses, prev comma dp square bracket I minus 1. Come outside of that, we're going to say square bracket j. Come outside of that, we're going to say square bracket c. Then we're going to come underneath this, and we're going to say if j is greater than 0, we're going to open up the brackets, and we're going to say prev equals max, open up the parentheses, prev comma dp square bracket I square bracket j minus 1 square bracket c. Boom. And if no valid previous state, then we'll skip. So we'll come underneath this, and we'll say guard prev is greater than or equal to 0, else we're going to open up the brackets and continue. Boom. Then we're going to add the current cell's cost by coming underneath this. We're going to say let new cost equals c plus cost. Boom. And we're only going to proceed if we don't exceed the allowed cost k. So we're going to say if new cost is less than or equal to k, we're going to open up the brackets, and we're going to update dp with the best possible score. So we're going to say dp square bracket I square bracket j. Come outside of that, we're going to say new cost. Come outside of that, we're going to say equals max, open up the parentheses, we're going to say dp square bracket I square bracket j square bracket new cost. Come outside of that, comma prev plus score Sorry, y'all, this comma should be outside of the parentheses. Boom. Then we need to close these parentheses. Or, sorry, y'all, this parentheses should be out here. Boom. And then we're going to come all the way down here. And we are going to say, let result equal dp square bracket m minus 1, come outside of that, square bracket n minus 1, come outside of that, dot max, come outside of that, question mark, -1. Then we're going to come underneath that and we're going to return results, y'all. Boom. So let's give this a run. See what happens. Okay, so let's see. Oh, this max should have a parentheses like this. So let's go ahead and give it a run now. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Boom, look at that, y'all. 49 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.